Rayyan.
Yes, sir.
So we were discussing some questions. So we have discussed
Yeah.
already two questions. Now we'll discuss the third question. So in this question is also based on the graph. So in this question, it is given that from the velocity time graph, basically this is a velocity time graph.
Mm.
From the velocity time graph given below, for a body projected vertically upwards. So when a body, there is a body and this body is projected upwards.
Yeah.
So what will happen? So this body will go up, 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 and after a certain period of time, this body will have the zero velocity, and finally this body will
Mm.
move in the downward direction. So finally this body will be at the ground.
Mm.
Okay, and this is the ground. Okay, so now you can see in this graph, this is the same condition, and this is a graph plotted for a body is moving in the upward direction. So for the from the
Mm.
velocity time graph given below, for a body projected vertically upward, find the velocity of projection. Find the velocity of projection. What is the meaning of the velocity of projection? Means what is the initial velocity with which you have projected the body. Okay, this is the velocity of projection.
Mm.
Okay, so velocity of projection. Now you can
Mm.
see in this graph. In this graph, you can see at time t is equal to 0, what is the velocity? Plus 20. At time t is equal to 0, the velocity is 20. And there is one more value that is minus 20. So if with respect to the graph, you will see, na, for time is equal to 0,
Mm.
what is the velocity? 20. So
Yeah.
at time is equal to 0, the velocity will be the velocity of projection. So at t is equal to 0, the velocity will be velocity of projection. Because at t is equal to 0, na, you are projecting the body. At t is equal to
Yeah.
0, yeah, the velocity is velocity of projection from the graph, that value that is the velocity of projection, that is u, is 20 meter per second.
Mm.
You can see from the graph, it is given in the graph. At t is equal to 0, at t is equal to 0, the velocity of the projection is 20. Now they are asking maximum height attained by the body. Maximum height attained by the body.
Mm.
Okay. So now this is the time 0. This is 2 second. This is 4 second. At time t is equal to 0, what is the velocity? 20 meter per second square. 20 meter per second. Okay. But actually this is given wrong. Here will be only meter per second only. This will be not there. It will be minus 1
Mm.
because it is meter per second. So at t is equal to 0, the velocity is 20. At t is equal to 2, can you tell me what is the velocity? 0. From the graph,
Yeah.
here at t is equal to 2 second, the velocity is 0. At t is
Yeah.
equal to 4 second, at t is equal to 4 second, again the velocity you can see in the graph is minus 20
Yeah.
centimeter. So for 0 to 4 second, okay, for 0 to 4 second, the
Mm.
body is in the motion, is in motion. Now
Mm.
the point where the velocity will become 0, here. Here the velocity will become 0, and this is the point of the maximum height. For 0 to 2 second, okay, at the second,
Yeah.
the body will be at, okay, so this is the time where t is equal to 0, and this is the time where t is equal to 2 second, and this is the time
Yeah.
where again t is equal to 4 second. So at t is equal to 2 second, the velocity is 0. Now for finding the maximum height, so this will be the maximum height of the body. So we can find what is the initial velocity, that is 20 meter per second. Okay, initial velocity is 20 meter per
Yeah.
second. And what is the
Okay.
acceleration? Acceleration will be minus g. Okay,
Yeah.
minus g, because this is the motion under gravity. So acceleration
Yeah.
will be minus g. Why minus g? Because g is always in the downward, and velocity of
Yeah.
projection will be in upward. After that, what is the final velocity is equal to 0, and what is the time? 2 seconds.
Yeah.
There is a time of 2 seconds. Okay, for becoming
Yeah.
the velocity 0, and velocity becomes 0 at the highest point. Velocity becomes 0 always at the highest point. Okay, now you can apply
Yeah.
v
Okay.
is equal to u plus at, and you will get the answer. Apply v is equal to u plus at, and you will get the answer. Not v is equal to u plus at. You have to apply v square is equal to u square plus 2as. Now v square, this is 0 square, u square v is 20 square plus 2 into the value of g you can take minus 10 meter per second square. So it will be minus 10, and h you want to find. So from here you will have 20 square divided by 20. So it will be 20 meter. It will be 20 meter. Okay, now please write down the question as well as the answer, because this is, I will say, a good question. Okay, this is a good question.
Okay.
Hello, Rayyan.
Yes, sir.
I was disconnected. Just a minute. Write down.
Yeah.
Rayyan, are you getting my voice?
Yes, sir, I am.
Okay, so write down.
Yeah, okay.
Yeah, I was disconnected that time. Done?
No, not yet.
Oh, okay. When completed, you can tell me.
Okay, sir.
Okay, now we'll discuss another question.
Hmm.
This is also a good question here. You can see this graph is given, and the graph is given for P. The graph is given for
Yeah.
P and Q. Okay, it is given. The figure given below shows the displacement time curve of particles P and Q. So there are two particles. One is P, another is Q. Okay, there are two particles, and this graph is given, and this graph is the displacement time graph. This graph is displacement time graph. This is the origin. Now they are saying which of the following statements are is correct. Which of the following statements is correct?
Hmm.
So first statement is given: both P and Q move with uniform speed. Move with uniform speed. Now there was a term. There was a term in displacement time graph, slope. Slope of displacement time graph, I told you, is the velocity.
Hmm.
Slope of the displacement time graph is displacement divided by time. It is equal to velocity. And this is also given by tan of theta. Now, for this graph, there is one this graph Q, and there is one this graph P. So first we can find theta. So here will be a here will be a horizontal line like this. Here will be a horizontal line like this. So this type of horizontal line you will get, and basically this will be the angle. Suppose this is angle theta p, and here there will be an angle that is theta q. So now can you tell me which angle will be greater, theta p or theta q? Theta q.
Theta q.
Yeah, this theta q will be greater than the theta p. So if this theta q is greater than the theta p, then slope of, you can calculate the slope of p and slope of q. Slope of p is equal to tan theta p, okay, and slope of q, slope of q is equal to tan of theta q. Theta q. Now we know that theta q is greater than theta p, so you can say slope of tan theta p will be greater than tan theta q. So you can say slope of p is greater than slope of, oh sorry, actually theta is greater than theta q is greater than, so you can write tan theta q is greater than tan theta p, means slope of q is greater than slope of p. What is the slope of displacement time graph? Velocity. So you can say velocity of q is greater than velocity of p. Velocity of p. And one more thing, if suppose this angle will be theta something, it means 30 degree or 40 degree, so this slope will be constant. Okay, this slope will be constant slope. Slope constant means velocity is constant. This slope will also be constant. I told you that in case of the straight line graph, the slope remains constant. In case of the straight line graph, the slope remain constant, or the velocity will remain constant in case of the displacement time graph. Now you can read the statement. Both P and Q are moving with uniform equal speed. No, both are moving with different speeds because the slopes are different. So this first option is incorrect. P is accelerated and Q is retarded. So there is no acceleration. Why? Because they are both the particles are moving with a constant speed, constant velocity. If the velocity will be constant, there will be no acceleration. Why there will be the acceleration? Acceleration will be only there when there will be change in velocity, but here the velocity is constant. You can see here velocity is constant. If the velocity is constant, you can write also here slope of p is equal to the velocity also, velocity, and this is also equal to velocity. So both the velocities are constant. If there is a constant velocity, means there will be no acceleration, or there will be no retardation. Means second statement is also incorrect. Now third statement, both P and Q move with uniform speed, right? Uniform means constant speed. Both P and Q are moving with uniform speed, but the speed of P is more than that of Q. Yeah, it is right. Okay, actually we have taken wrong theta. This will be theta Q actually. This will be theta Q, and this will be theta P. This will be theta P. So slope of P, now it is all right, because theta Q actually we have to change now. Slope of P will be theta P, and slope of Q will be this. So we have to change all these things. So which slope is greater? We know that theta P is greater than theta Q. You can see this angle is greater than this angle. So theta P is greater than theta Q.
Yeah.
So you can write tan theta P is greater than tan theta Q. So you can say that slope of P is greater than slope of Q. Means you can say velocity of P is greater than velocity of Q. So now both P and Q are moving with uniform speed, right? But the speed of P is more than the speed of Q. This is a right statement.
Yeah.
Why the speed of P is more than that of Q? Because the slope is greater for P. And fourth statement will be incorrect. Why? Because both P and Q move with uniform speed, right? But the speed of Q is, they are saying speed of Q is greater. But the speed of P is greater, we know. Okay, this is also a good question, I will say. Write down.
Okay, sir.
Yeah. Completed, Rayyan?
Oh, yes, sir.
Okay. See this question. Which of the following graphs indicates that a body is undergoing the retardation? Retardation. So we have velocity time graph, we have displacement time graph, and here is acceleration time graph. So retardation means the velocity is decreasing. Retardation means the velocity is decreasing with time. So we have to find out in which graph the velocity is decreasing with time. So see the graph number 1. So in the graph number 1, with time, the velocity is increasing or decreasing? It is increasing, na?
Increase. Yeah.
Yeah, it is increasing. Yeah. So it is increasing. So means if the velocity is increasing, means there will be no retardation. Retardation is happens. For example, I am giving you one example. Means suppose you are in a car and you are driving that car on the road. And you are driving that car with 100 kilometer per hour, and suddenly you applied the brake. Then what will happen? The speed or the velocity of your car will decrease. At the time when you applied the brake, from that time your car will be in retardation. Okay.
Yeah.
Your car will be in the retardation condition. Retardation means negative acceleration, means when the velocity is decreasing, that is known as the retardation. So when the velocity is decreasing with time means retardation. And suppose if you are in a car and you have the accelerator and you are increasing the speed with time, or is increasing the velocity of the car with time, in that case your car is in the accelerating condition. Or when you will apply the brake, your car will be in the retardation condition. So here the velocity is increasing with time, you can see. With time the velocity is increasing, so this is not the case of the retardation. Now here you can see this is acceleration time graph. So acceleration from the acceleration time graph, we cannot have any information because this is the acceleration time graph. Here with time the acceleration is increasing. So we cannot say if the acceleration is increasing, we cannot say that it will be a condition of retardation. So this will be not correct. Now see this this graph number 4. The displacement of the body is constant. Okay. Displacement of the body is constant with time, means the body is at rest. With time, the displacement of the body is not changing, means this is the case of rest. So if the body will be at rest, if initially the body has done some displacement, you can see here, but after that the body will be at rest. And if the body will be at rest, then there will be no acceleration, there will be no retardation, means the option number 2 will be correct. In this case, velocity is increasing with time. So you have to read the graph, because curved graph I have not told you. We have only discussed the straight line graphs. So this question I have taken because you have to eliminate the options and you can get the answer. V is increasing with time. Here in this graph, acceleration is increasing with time. With time. And in the second graph, means I am not going in detail because this will be not the part of your syllabus, the curved graph, because here also we can calculate the slope. So I'm not going in that because how we will calculate the slope, I'm telling you, you can take any point, and at that point you will draw a tangent, and you will draw a tangent at that point like this. Okay, and then you will see the angle with the x-axis, and that will be the slope of this graph. Okay, so graph number 4, in graph number 4 the body is at rest. Okay, so if the body will be at rest, so there will be no retardation, there will be no acceleration, nothing will be there. So that is why this graph is representing the condition of retardation. Means in this graph with time the displacement is increasing, but the velocity is decreasing. Okay, so you can just copy this.
Okay, sir.
Then we will discuss the next question. Done.
Yeah.
Okay. See this question. When they are saying when brakes are applied, okay, when brakes are applied means the velocity of the car changes from 40 meter per second to 10 meter per second in 10 seconds. The acceleration produced in it, okay, when the car is running and suddenly you applied the brake, in 10 seconds the speed is reduced to 10 meter from 40 meter per second.
Yeah.
Then what will be the acceleration? Just try to find out by yourself. I have told you many times what is acceleration. Very easy question.
Brakes are applied the velocity.
Yeah, just try it. No problem.
-5.
-5. It will be 10 minus 30. Actually, that will be -3.
Oh.
Actually, you are some means you have applied the concept, right concept, but you have applied differently.
Yeah.
Actually, you
Yeah.
have not regarded the direction here. You
Yeah.
can see if you have a car like this, you are getting, I can understand now. You can see if the car is moving in this direction. So when you will
Yeah.
apply the brake, then also the car will all move in this direction. Car will
Yeah.
not move in the opposite direction when you will apply the brake.
Yeah.
Car will move in the same direction again. If
Yeah.
the car will move in the opposite direction, then you have to take the negative sign. Okay. So this is your car.
Yeah.
This is car. And this is started from this point and moving like this on this track. So suppose here you have applied the brake and here the speed was 40 meter per second. So you have applied brake. Now your car, after applying brake, in 10 seconds, the speed of the car will becoming 10 meter per second. Now you have to remember one thing, the direction of the speed or direction of the motion of the car is remain same. Always the car is going in this direction. Always.
Yeah.
Okay. So this direction you can take positive direction. So now acceleration is what? Final velocity minus initial velocity divided by time. So final velocity is 10. Initial velocity will be 40 and this is divided by 10. So it will be minus 30 divided by 10. So in this way you will get -3 meter per second square. Understanding?
Yeah.
So if I'm saying that if a car is taking a turn, if a car initially, you can say, initially if the car is moving with 40 meter per second and in 10 seconds the car is taking turn and now the car is moving with 10 meter per second.
Yeah.
In this case your answer will be right. So you have to choose this direction as positive direction and this direction. You can take any direction positive, any direction negative. Now here the acceleration will be final velocity. Final velocity will be -10. Initial velocity will be 40 and this is divided by 10. So here you will have 50 by 10 means 5 meter per second. Right down. So you have to keep in mind the direction.
Yeah. Sir, can you scroll down?
Yeah.
Okay, sorry, we're done.
Done?
Yeah.
Okay. Okay, so now this graphical relations and